Hello everyone, this is going to be a tutorial on how to deploy a Python machine learning project using AWS Lambda. I'll be using Docker to package my Python application and AWS Lambda to run the machine learning project. The purpose of the video will be to illustrate how you can take a local data science project and convert it to production ready. There are many ways you can deploy your code, but I find using AWS Lambda to be easy and low cost to use. For example, your entire project doesn't need to be on AWS. You can literally just use AWS Lambda to run your model and then send the results or predictions to whatever other application needs it. I'll be using the free tier on AWS so that anybody at home can follow along for free or at a very low minimum cost. Okay, before actually getting started with the deployment guide, I just kind of want to walk through a couple steps needed in order to set your environment up for those who want to follow at home with deploying this little project onto AWS. So the first thing that you'll need is the AWS command line interface. Pretty easy to do. AWS has pretty good documentation on how to do this. I'm on an Ubuntu Linux based operating system, so I'm just going to look at the Linux installation steps. And it's literally copy and paste. So I'm going to copy this. I have a terminal open. I'm just going to paste that and you would just hit enter. I already have AWS installed, so I don't need to do that. But just to verify that it is here, I'm just going to type in AWS version and you can see that it exists there. The next thing we need to do is configure AWS. In order to configure the console so that you have access to your account, you need to something called an access key. So in order to get an access key, you go to the IAM, you or whoever gives you account privileges, whatever. You want to go to users and select the user that you want to use. You can go to security credentials and you should have an option here to create an access key if you don't already have one. I already have one, so I'm not going to do that. But just to illustrate how to set this up, I'm going to use this example. So I'm going to type in on my terminal, AWS configure, and I'm going to give it an additional argument. I'm going to give it profile. I'm going to call it something, profile XYZ. And it's going to give me a few questions. It wants the AWS access key ID. I'm just going to copy this one and paste it on there. Next, it wants the secret access key. And the region name. I'll use US East 2. And I'm just going to leave that one blank. And we're done. The next thing that you want to do is make sure that you have Docker installed onto your machine. And just like AWS, Docker has plenty of guides on how to do this. You can even look up different YouTube videos on how to install Docker onto your computer. Again, I'm using an Ubuntu-based machine, so that's why I'm looking at these Ubuntu-based installation steps. So a lot of these steps are essentially copy-paste. You would copy these commands and paste them onto your terminal. And you would just hit enter and just proceed. I already have Docker installed, so I'm not going to follow along with these steps. But when you get to this step, you essentially have Docker. And you could test Docker by running this simple hello world test. I'll go ahead and run that. And if you do follow along correctly, you should see something similar. The last thing that I want to show you is this Amazon ECR Docker credential helper. A lot of you, if you've seen Docker in the past, you might have seen something like Docker login, and depending on your setup, that might not be the best practice. So in this tutorial, I'm not going to be using Docker login, and just to explain why, this is why. You can read this documentation, kind of figure out why I'm using this. But essentially, in order to set this up, again, we're going to be doing some more copying, pasting, copying installation, and hit enter. I already have that installed onto this machine, so I'm not going to do that. But once you have that set up, there are some configurations that you need to do. You need this .config file sitting in that .docker directory. So you can use any editor. I'm going to use Vim, and I'm just going to paste that. And this is what currently exists in my .config file, or config.json file. You can see that it's exactly that. I probably literally copied and pasted it. But with this configuration, it avoids needing to use Docker login. And what we'll be using instead in this tutorial is something that looks like this. So we'll be using this environment variable, AWS profile. Instead of my profile, you would give it whatever profile you created or configured the console with, and you'll pair that with the Docker pull, push, whatever. And just like this says, there's no need to use Docker login or Docker logout. And that's basically how to set up your local environment with AWS and Docker. And from here, we'll just kind of proceed with the guide on deploying the project onto AWS. In my GitHub repo are contained all the code files and steps needed to get started with this project. And towards the bottom of this front page, I have this deployment process path that I've designed. So now I just want to go over the deployment process that I'll be following in this tutorial. The first will be to build the machine learning model. Next, we'll package that machine learning model into an application by designing and implementing a pipeline that can ingest new data, run our model, and then save our predictions. We'll package the code using Docker. Finally, we'll create the AWS resources such as S3 and Lambda to run our model. We'll upload the Docker image into ECR. And finally, we'll test and deploy the machine learning application using Lambda, and we'll set up any deployment triggers that are needed to run our code automatically. So in this tutorial, I'll be using this emotion and classification NLP dataset, and just want to talk a little bit about it. The main scope will be to take in text messages and label what type of emotion is associated with that text message. Here you can see that in the first few examples, a lot of these are associated, or all of these are associated with joy. Since we're dealing with text data, we'll need to design a pipeline that will be able to take in the text data, clean the text, and decode some of these emojis that are contained in the data set. Once we clean the data, we'll need to vectorize the data, and then you build a classifier that will be able to classify what type of emotion is associated with the text. So in order to get started with the project, the first thing that you'll need is this Git repo. You can clone it locally by downloading it. You'll need Git and a terminal. So you want to copy the Git link, and on the terminal you want to type in git clone and the link. I already have it locally, so that's why I'm getting this fatal error. So you can see that deploy Python ML sits in my projects directory. So I'm just going to go to deploy Python ML. And as stated, this is a Python project, so you'll need Python installed if you don't have that already. In this guide, I'll be using Anaconda, or actually Miniconda. So if you don't have that installed, I recommend that you do, just so that it's easier to follow along. To follow along with the tutorial, make sure that you create a Conda environment. You can do this by typing in Conda create and then the name of your environment. You can see here that I'm getting a warning because I already have a Conda environment called tutorial. So once you create the environment, all you need to do is type in Conda activate tutorial, or whatever the name of your environment might be. So following the deployment diagram that I put together, the first steps that we'll need to do include the are under model development. So we'll need to build the machine learning model. So in the project directory, we have this script called build_model.py, and I also have this directory called model dev. So I just want to talk a little bit about the machine learning model. I've outlined the steps that I took in order to build this type of model. So the first are loading up the NLP dataset. Again, I'm using that Kaggle dataset, so all I did was download to my computer. I built some functions to clean the text. I used Spacey to tokenize the text, and I used this emoji library to decode those emojis that were contained in text messages. Next, I trained a vectorizer using scikit-learn, and then I vectorized the text data, so that I could then train my classifier. And finally, also validated and tested that classifier. Lastly, you want to save the vectorizer and the classifier, and then begin building out that machine learning pipeline in a more contained manner. So I have this script called build_model.py that sits at the top of the project directory. And we'll be using this script to essentially build the machine learning model. The steps I outlined in the diagram are contained in this script. So all you need to do is basically run the script and it'll do everything automatically for you. Again, I'm not focusing on model development, more deployment. So in order to build the machine learning model, you want to run two scripts. The first will be this install requirements script. So if we take a quick look at it, you can see that I'm using Conda to install some libraries, as well as using pip to install some of the other libraries. I'm using pip to install NumPy, pandas, and some of these other libraries because I found that using Conda to install NumPy caused issues when trying to package this up within Docker. So in order to avoid any issues, I'm sticking to pip. Now, in order to build the machine learning model, all I need to do is type in Python build model.py. Now that the script has completed running, I just kind of want to go over some of this output. So we saw that we ran the script, it loaded the data set, it processed the data set, and then it created that TF-IDF vectorizer to convert our text data to a numerical form. Next, it built the classifier and finally ran the predictions. And you can see that at the very far right column of this data frame, we have our predictions associated with each of the text messages that we got. And finally, at the bottom, I printed out this classification report. I'm not really interested in the performance of this model. I'm just using this as an example to just use as something to deploy into AWS. Now that the model is built, we can begin working on our application that will contain our machine learning pipeline with all the functions and dependencies needed to prepare our data, load our data, prepare our data, load our model files, and then make our predictions. So in this project, I have this app directory, and that's essentially my machine learning app. So this directory has essentially one main module and two submodules. The main module is app main.py, and in that module, there's this function called handler that AWS will use to essentially run our pipeline. The two submodules are model and then pre-processing. And model essentially loads up our machine learning model files, and then pre-processing essentially takes care of all the text pre-processing that is needed before running our machine learning, or running the data through the machine learning models. So now I want to just briefly go over the general machine learning pipeline that I usually use when deploying my models. So what we should expect is to first receive some new data from whatever source that might be. We want to pass that data into our machine learning pipeline. And then finally, we want to create an output that will be stored somewhere for further use. So when we receive our data, I am expecting to receive that data through some process that's creating that data and then putting it into an S3 bucket in AWS or some database that I can access. I'll need to design my pipeline to load in that data from S3, a database, or whatever that might be. Next, we'll need to work on the machine learning pipeline part. So that includes cleaning the text data, loading the machine learning files, vectorizing the data, the text data, and then finally loading our classifier and running the data through our classifier to make predictions. Lastly, once we have our predictions, we want to do something with that output, and that might include loading into a database or simply just putting it into an S3 bucket as a CSV file for somebody else to pick up. So with this app structure, I essentially designed this to follow the workflow needs that I explained earlier. I need to be able to read in the new data from S3, and finally also return the predictions as a CSV file to S3. And all of that is essentially handled by this function called handler. So if we look at the main.py file and scroll down to where we have handler, you'll see that I'm using some functions to load my data from S3. I'm loading my model, making some predictions, and then saving those results to S3. So just to show you a little bit around the other submodules, first take a look at the model submodule, and in here I essentially have my model files that are saved through joblib, and I have a machine learning pipeline script here. And what I've built here is a class called ML Pipeline. This class takes in two objects, the classifier and the TF-IDF vectorizer. And what we're doing here is we built this pipeline using the two classifiers and the classifier and the vectorizer. And when we want to make a prediction, we clean our text data, and then we process the data, or we transform the data through our vectorizer and finally make some predictions. Now to show you the other submodule, preprocessing. Preprocessing contains all the functions needed to handle, clean the raw text data. There are two libraries that I rely on, Spacy and Emoji. I use Emoji to decode those emojis, and then I use Spacy to tokenize the text data. And I use Spacy to tokenize the text data before it's converted into a matrix form. At the top of preprocessing, I have this init file, and in this init file, I have that clean text function that calls on the Spacy tokenizer, and then that decode emojis function that I wrote up. So that summarizes a quick high-level view of my application. And again, the main focus of this application is just to be able to receive incoming data from S3, load my model, make the predictions, and then return the output back to S3. So returning back to this deployment diagram, we've designed our pipeline in our application, and the next step is to test it locally. So going back to the top of my GitHub page, I outlined the steps needed to to test the application. So I'm just going to copy this command and paste it onto a terminal. So on terminal, I'll paste the command, and make sure you're always including this running local true whenever you're running the application locally on your machine. And now I'm going to run and wait for the application to complete running. Okay, now you can see that the test has run successfully, meaning that my application is able to pick up new data, run the model, and make predictions. And you can see at this bottom output, printing out that data frame with the predictions at the very far right column. So returning back to this deployment diagram, again, we're under package ML app. We've designed our application, designed that pipeline. We've tested it locally. And now the final steps are to package the code along with all its dependencies. And then we're also moving along to deploy this into AWS. So what you'll need to do next is to make sure that you have, if you want to follow along at home, that you have AWS and Docker configured onto your local machine, and also that you have access to your AWS account. What you'll need to do is you want to create a repository on using Elastic Container Registry on AWS. So I'll click Create Repository. You'll give it a name, something like my project, and you'll hit create repository. I already have an existing repository, so I'll just hit cancel. So looking at my repository, the name of my repository is called NLP ML Tutorial. And now in order to get my my code into this repository, I can just follow along with these push commands. Now, if your local setup is similar to mine, there's some skipping around we might need to do with these steps. Otherwise, you can follow along and just literally copy and paste some of these commands onto your terminal. But since my installation has been configured with my own specific settings, I'm going to skip the very first setting since I don't need to log into AWS using Docker. I'm avoiding this for security reasons. And so I'm proceeding next to step 2, which is using Docker to build my Docker image and NLP ML tutorial. So I'll copy this command and I'll paste it here. Now, when I run this command, it's going to call on a file called Docker file. This Docker file is contained at the top of the directory, and without going into too much detail about Docker, it essentially collects all the dependencies, it runs all the setup scripts, it copies the code, and it places it all in a Linux image that can then be used by AWS Lambda. So if you have a project at home that is somewhat similar to what you're seeing here, you can go ahead and copy this Docker image file. Otherwise, there are plenty of resources online that should help you out to set up your own Docker file for your own setup. So going back to the terminal, we're now going to run this command to build our Docker image. And I'll just let it run. Now that the build has completed successfully, we can go over to the next step. So the next step is to tag our Docker image. So I'm going to copy this command under step 3 and paste it. Finally, we're at our last step, and that is to push this built Docker image up to ECR so that we can then use that image to build our Lambda function. So I'll paste that command. And as I mentioned previously, I have some additional settings that allow me to bypass that login. So I need to add an additional argument here, and that is AWS underscore profile. And I'm going to give it the name of my profile. And now I can run that and it'll upload the Docker image over to Docker or to ECR. Okay, after some time, the Docker image has uploaded to ECR, and if we go over to ECR, we can see that the latest image has been uploaded. That leaves the remaining step to start creating the Lambda function. So just taking a quick minute to look back at the deployment path, we've just wrapped up the second stage of deployment, package DML app. And so we just finished packaging the code into a Docker image and uploading it into ECR. And our focus will now be to configure AWS and the resources needed so that we can run our model using AWS Lambda. For my deployment, I'll be using S3 as the source of my incoming data, and I'll be running the model through a Lambda function. So there are two items I need to set up. That is an S3 bucket and the Lambda function. I went ahead of time and created a S3 bucket, so this is already sufficient enough for my deployment needs. Next, I need to set up the Lambda function. Before creating the Lambda function, I first need a execution role for the Lambda. And an execution role basically just enables the Lambda function to access certain resources such as ECR, S3, RDS, database, source, anything that you might need for your Lambda function, essentially. I already have an execution role, so I'm just going to skip over this step. Now that I've created any AWS resources that I may need for my Lambda function and my pipeline, I can finally create and configure my Lambda function. And that is the third step under deploy AWS. So I'll start by creating my Lambda function by just clicking on create function. I have a container image. I'm not going to try to create a Lambda function from scratch. I have uploaded the image to ECR, so I'm going to use that instead. I'm going to browse the image or browse for images, and I'm going to select NLP ML tutorial. And I'm just going to go ahead and use the latest uploaded image, which is uploaded 19 minutes ago. And I will call it NLP ML tutorial. And as an execution role, I'm going to use an existing one. I created this role, data science role. And finally, I'm going to click create function. Now that my Lambda function has been created, the next step is to configure this Lambda function and edit any default settings. I'm going to click configuration and then general configuration on the left. I'm going to click edit and I'm going to give it a description. Next, I'm going to increase the memory to 2000 megabytes. And I'm going to increase the timeout to 2 minutes. And then, finally, once I'm done, I'll click Save. Looking at the deployment diagram, we've created our Lambda function and it's been configured. So we're at the final phase where we just need to test the Lambda to ensure that everything runs as it should and set up any final settings and triggers that will then allow our Lambda function to run automatically whenever there is new available data. So first, let's look at how to test our Lambda. I'm back at the Lambda function, and I'm going to go to the Test tab. Now, the way I've designed my application, it expects to receive data from S3. So I'm going to create a test that would pick up a test file sitting in S3 location, and with that test file, run my model, make the predictions, and then write an output. So there are multiple templates for this. Click the Templates tab and just scroll down to find S3 put. In this JSON file, or this event file, there are two things I need to configure. I need to configure the name of the bucket, and then I need to add the path to my file. So going back to S3, I'm going to click my bucket, and I've uploaded this file, emotion labels test dataset. And I'm going to use this as my test dataset. So the two items that we need will be the name of the file and the bucket. So first, I'm going to replace the name of the bucket. And then next, I'm going to change the name of the key, which is just the file path. Now that I've made all the changes that I need, I'm going to go ahead and save this test. And we'll call it, give it a name. I'm going to call it S3 put test data. And then I'm going to hit save. Now that my test has saved, I'm going to go ahead and test the Lambda function. After running the test, I noticed that I got a failed result. And looking at the details, I noticed that 2 minutes was not enough time for the Lambda to run. So I'm going to go back to configuration, and I'm going to increase the time over to 3 minutes. Now that the configuration settings have updated, I'm going to go back to test. I'm going to clear out this old test, and I'm going to rerun that same test. Okay, our test has finished running, and you can see that we received a success message, meaning that our model picked up the data and made predictions and was able to output those predictions. So if we look at the details, you can see that I got back my success message with a smiley face, and just like in the past, we got this new column all the way on the right with the predictions. And you can see that the predictions were saved to this bucket. This S3 bucket with a label predictions.csv. So now if we go to our S3 bucket, we should see a predictions.csv file, which is right here. So I've gone ahead and tested the Lambda, and everything ran successfully, leaving me with one last step, and that is to apply any last minute settings and event triggers to finalize the deployment process. So I'm going to go to my Lambda function, and I'm going to add an event trigger. And again, that will just allow the Lambda to kick off whenever there is a new data set. So I'm back at my Lambda function. I'm going to go to configuration. There's a tab called triggers, and I'm going to add trigger. The type of trigger I want to add is an S3 trigger. I'm going to choose my bucket, and it will be an S3 put, meaning somebody or something is going to put new data into my S3 bucket. And there's a specific path where the new data should be expected to be placed, and that will be called NLP new data. And the type of data that I'll expect to receive, it will be just a CSV file. And finally, I'm going to check off this box, acknowledging that I'm both reading and writing to the same S3 bucket. Finally, I'll click Add. Okay, now that the trigger was successfully added, it's time to test this entire pipeline by uploading a new data set to that S3 location. So I'm back at my S3 bucket, and you can see that the only two files that I have here are, well, one file. It's just that emotion labels test CSV file, and then this new directory called NLP new data. And inside this directory, it's empty. So I'm going to upload a new file. And I'm going to upload the emotions labels validation dataset. And click upload. Now, once this is uploaded, this should kick off the Lambda function. And what I should expect to see is that in this S3 bucket, I'll receive a new predictions.csv file. So I'm just going to wait a minute for this to show up. And if it shows up, that means that the entire process has completed successfully. Okay, now that after letting this sit there for a few minutes, I have come back to a predictions.csv file, meaning that when I placed a new data set inside this NLP new data directory, the Lambda function containing my machine learning project picked up data, it cleaned the data, ran the model, made the predictions, and placed this new output into my S3 bucket just how I designed it to do. So now in conclusion, that basically fulfills all the steps in this deployment path. So we've developed our model, we packaged the model application, we deployed it to AWS, and then we tested it and finalized the deployment process. And even though this was using a mock data set, the machine learning model was fairly simple. I do think that this illustrates a lot of the essential steps needed to deploy a machine learning application onto AWS. And again, there are multiple ways of deploying a machine learning project. I just find that AWS, Lambda, and Docker are such easy approaches that they're easy for any newcomer to come and pick up. If any of you have any general questions, feel free to leave a comment below and I'll try to provide any suggestions or feedback. And again, thank you for watching, and hopefully this was useful to anybody who is new to machine learning and deploying applications.